Okay guys, third video. Now we're going to take a look at a factoring technique called factoring by grouping. And factoring by grouping is often used when you have four terms. So if you look at problem number 7, you'll see it has four terms. And I'm going to walk you through an example first, and then I'll kind of show you a generalization for it. So this works when you have the first two terms and you can factor something out of both. So let's see. We could factor 9t squared out of both of those, leaving us with 3t plus 5. And you can factor something out of the last two terms. So looking at the last two terms, we could factor -1 out of those, leaving us with 3t plus 5. And you'll notice that we got 3t plus 5 in both places. So this is similar to if you had something like this. If you had 9t squared times a, let's say, minus 1 times a, both of them have a factor of a. You could factor out the a, and you could leave 9t squared minus 1 as the other factor. So the same idea applies here. We have 3t plus 5 in both places. We could factor out 3t plus 5 and leave 9t squared minus 1 as the other factor. It's not necessary to put them in this order. You're welcome to put 9t squared plus 1 first and 3t plus 5 second. And then you should always pay attention to what you get for your factors and see if they factor further. So 9t squared minus 1 is a difference of squares. It factors more, so we'll keep going. And we have 3t plus 5 times 3t plus 1 times 3t minus 1 as our answer to that problem. Okay, so to summarize what we did is we took the first two terms, factored something out, took the last two terms, factored something out, and if it works out that the remaining factors for both sides are the same, then grouping is working and you can keep going. Sometimes you'll see grouping problems where you do 3 and 1 instead of 2 and 2. We'll cross that bridge when we come to it. So up here, I don't know if you're going to find this helpful or if it's just going to look like a bunch of letters to you, but you'll notice I kind of made a formula. So if you take the first two terms, you could factor r out of them, which is what we see here. And if you take the next two terms, you could factor s out of them, which is what we see here. And that leaves you with a plus b both times. So then you bring together, you factor out the a plus b, and that brings together the r plus s. So our final answer is r plus s times a plus b. Let's try another one. Okay, x cubed plus 7x squared minus 9x minus 63. And of course, you can always pause the video if I'm going too fast, and if you need time to catch up and think about it or write. I'm going kind of fast right now because I am running out of time to record this. So please feel free to pause. Okay, I'm going to factor something out of the first two terms here. It looks like you could factor out x squared from both. And then factor something out of the last two terms here. You could factor negative 9 out of both. And because we got x plus 7 both times, grouping is working, so keep going. And you end up with x squared minus 9 from the first parts multiplied by x plus 7. That's the common factor. And then just like we saw in the previous problem, we happen to have a difference of squares. So you can factor the difference of squares into x minus 3 and x plus 3, and you still have the x plus 7. The next one incorporates grouping into an equation. So it says solve the equation. Chances are we're going to end up using grouping in there as we do it. So here we have four terms on one side, it equals 0. And remember the zero product property, which tells you that if you have a times b equals 0, then either a equals 0 or b equals 0. We used that previously in chapter 4. So we want this to be in a factored form. So looking at the first two terms, we could factor g squared out of those. Looking at the last two terms, we could factor -1 out of those, leaving us with g plus 3 in both places, so grouping is working. So factor out the g plus 3, and the other factor is g squared minus 1. Once again, we have a difference of squares. It's not that you always will, it's just that these problems happen to be written very similarly. So factor the g squared minus 1 into g minus 1 times g plus 1. And we have three factors that we can set equal to 0 and solve each one. Okay, so then we're going to solve each one. We get g equals 1, g equals -1, or g equals -3. All right. Next, I think you ought to pause the video and do these problems for practice. And then when you resume the video, you'll see that I have already worked them out and the answers will be on the screen along with the work. And so you can look through it, pause as needed, and check your work. All right, here we see the worked out solutions to both of those problems. Number 10 was pretty straightforward, similar to the other examples we did. And number 11, as we got down there, you might have noticed that we came up with some non-real solutions. And sometimes as we move further in the chapters and we're not really talking about non-real solutions anymore, sometimes they're not including those in the book. I'm not really sure whether or not your book would include those solutions, but just to be thorough, we have all three. Okay, let's take a look at what is next. Okay, now this is a special name that I've given this kind of problem. You're not going to find this name in the book. I call it a quadratic in disguise. When you look at this expression, you'll see that it is to the fourth power, so it's a quartic expression, not technically quadratic, but the reason I call it a quadratic in disguise is because you can use quadratic-like techniques to factor it. So if this was a quadratic expression, chances are what you would do is just break it down into two binomials like this, and you would say to yourself, what times what gives me 3a to the fourth? So then you could just say probably 3a squared and a squared. And what times what gives me 24? And here you might have to fiddle around with it a little bit. So is it 6 and 4? Is it 8 and 3? Does it even work? So let's see, I think I'm going to try putting an 8 here and a 3 here, a negative here and a positive there, and look at the insides and the outsides, and that does work. Okay, now then, can you factor it any further? Is either one of those a difference of cubes, a difference of squares, or a sum of cubes? In this case, the answer is no, so that is factored as far as we can go. But in another problem, maybe you would be able to go further. Okay, one more problem in this lesson, kind of more of a word problem. The dimensions of a rectangular prism are x minus 1, 2x, and x minus 4. The volume is 40 cubic units. Find the value of x. And again, I apologize to be rushing, but I'm almost out of time to make this video, so just pause if you need to. A rectangular prism is often called a box. A rectangular box. So just for a quick sketch, we can draw a little box, and its dimensions are x minus 1, 2x, and x minus 4. How do you get the volume of such a box? Length times width times height. So we can multiply x minus 1 times 2x in whatever order you like, times x minus 4, and that should equal 40, the volume given. Now we have to solve this equation for x. So what we're going to do is multiply all of that out. I'm going to leave the 2x, and I'm going to FOIL the other two together. Now I'll multiply the 2x through. And then subtract 40 from both sides because you want to get it in the form where you can factor it and then set each factor equal to 0 and solve it using the zero product property. Okay, let's use grouping from here and factor 2x squared out of the first two terms and factor 8 out of the last two terms. And notice that we do get the same factor each time. We get x minus 5 and x minus 5, so grouping is working. And then finish the grouping process. And now we have our two factors. Set each factor equal to 0. And solve each one. And it probably won't take you very long to realize that what's going to happen over here with this one is you're going to end up with imaginary solutions, and it doesn't make sense for a box dimension to have an imaginary number. So eliminate those. Those are extraneous. X equals 5 is a possibility. Let's go back and look. Could the box have dimensions? 5 minus 1 would be 4, 2 times 5 would be 10, and 5 minus 1, or 5 minus 4 would be 1. 4 times 10 times 1 would be 40. So 40 cubic, what were they? Inches, units? Units. 40 cubic units. So that seems to make sense. So x is 5, and the problem just said find the value of x. So there's our answer. Okay, I hope you all have a wonderful winter break. Have lots of fun with your families and your friends and get lots of rest and do fun things. I'm sorry about giving you homework, but hopefully you'll get a lot of it done while you're in class today and you won't have to worry about it. Okay, I'll see you in the new year.